To introduce our third speaker for the day, we now request Mr. Bakul M. Shah, past Honorary Secretary, IIF Chennai Chapter, to introduce Dr. Ajay Kumar, Associate Professor, IIT Tirupati.
It is an honor to introduce our next speaker, Dr. Ajay Kumar, an Associate Professor in Department of Mechanical Engineering at IIT Tirupati. Dr. Kumar is a distinguished academician and researcher with a robust background in materials and mechanical engineering. He earned his Bachelor's of Engineering from MITS Gwalior in 2008, followed by an MTech in Materials Engineering from MANIT Bhopal in 2010. He received his PhD in Mechanical Engineering from Indian Institute of Sciences, IISc, Bangalore in 2016. Dr. Kumar furthered his expertise through two postdoctoral fellowships in the US, first at Washington State University and later at the University of Wisconsin, Milwaukee. His core research focuses on advanced metal castings, metal forming, material processing, and tribology. He has authored over 40 journal publications, 4 books, and holds 4 Indian patents. In recognition of his contribution, he was the winner of Chandran Mohan Memorial Award for Applied Research and Innovative Technology for 2022-23, presented at the 72nd IFC. At IIT Tirupati, he established a Foundry lab and serves as a coordinator for Foundry 4.0 Students Activity Center in association with Institute of Indian Foundrymen, IIF Chennai Chapter. Please join me in welcoming Dr. Ajay Kumar.
Okay, so very good afternoon to all of you. And at the outset, I would like to thank the organizer, especially Ambu Selvan sir and his entire team, for giving me this opportunity to present and share my experience on next-gen friction stir engineered aluminum composites. So this is a relatively new topic. Some of you may be aware. So now today we are talking about aluminum castings, especially aluminum die castings. And here I would like to introduce the role of friction stirring, which can play a very significant role in making these components when you are talking about the defects and when you are talking about the automated detection during the manufacturing itself. Karthikeyan sir was talking about it. So, so now we all are aware what are the advantages of aluminum. Being the lightweight material, we all are using aluminum material for different applications. So now here I would like to introduce the aluminum composites. So aluminum composites, as you know, when you want to make a composites, you mix the aluminum as a matrix material along with some second phase materials. It can be a ceramic material or it can be other alloying elements. So that is how you make the composites. So you have the matrix as aluminum, then you have these second phase materials. It can be any ceramic materials. You start from silicon carbide, alumina, boron carbide, right? Those type of materials you can use for making these composite materials. Now you will ask a question, why do you want composite when you have aluminum alloys? When you have aluminum monolithic material, you have aluminum alloys. Why do you want another grade or another type of composite materials? So when you take aluminum as a material, right, it is giving you the monolithic properties. You will have a set of mechanical or material related properties, but when you make the alloys, you will say I am going to increase the strength of the alloy, being mixing or putting the lot of other alloying elements. But when you mix the other elements, that is non-metallic elements, in for example ceramic materials, you again further increase the properties of the material overall. So now another thing which I would like to share here is the friction stir engineering. So all of you are making the different components using the die casting or different casting process, and all of you are also agreeing that we are getting a lot of defects in the casting, which you want to know, measure, and also you want to eliminate. And Karthikeyan sir told that no, you cannot eliminate the defects, you can minimize the defects. So the percentage of defect which is acceptable, which you are still considering for your products. Now, all of you are aware about the microstructure which is there in the material. So microstructure plays very important role. So after all you make the castings, you have to go through the microstructural testing, or you can go through the what you call mechanical testing, right? Now we have non-destructive testing. So this city, all these city related things comes under the non-destructive testing, where you are not cutting or where you are not destroying the material. Instead of that, you are putting the entire component into the city and getting the image out of it. So when you see this microstructure, you have the second phase, you have the grains, and then you have the second phase material. Now it is very important how do you place these second phase materials inside the matrix material. So matrix materials has its own microstructure, and then you are putting the, let us say, ceramic material inside the matrix material. Now today is the time where we all are talking about P&T, means positioning, navigation, and time. So how do you position your second phase material into the matrix system? That will decide the properties and performance of the component. Now here I am talking about the friction. So friction is basically, all of you know that when the two different components are sliding each opposite each relative motion, right, you have a friction between them. Now this friction, so this friction basically is being generated when you have this friction. This is called the friction stir tool. So you have this friction stir tool, and then you have this, let us say, is a cast component or casting plate, and then this tool you are rotating and also embedding into the what we call the metal plate. So when this tool, this is the shoulder, when this shoulder will touch to this metal surface, the friction will be generated. Due to that friction, the frictional heat will generate. That frictional heat will plasticize the material, and it will not melt the material, it will melt the material. So we say you don't need to melt, you have to melt. So that plasticizing basically is happening, and that plasticizing will also help to mix the second phase material into the matrix material. So that is how you try to, there are many advantages of this process. First is you are refining the microstructure. So when we say refining the microstructure, you have the grains and grain boundaries in the material, right? And then you say I have 2 micron grain, you have 5 micron or 10 micron, 100 micron. So any casting, you also see a lot of dendritic grains, right? So those dendritic grains, you must have seen the Christmas tree structure. Some of those dendrites also creates problem in the, because dendrites are not favorable for the very good properties in the component. That is how we want to refine the microstructure. So this process is also helping to refine the microstructure, removing the defects. Now we will say how it will remove the defect. When you are doing this stirring operation, whatever defects will be there in the cast plate, right, all those defects will be eliminated, because you are doing the microstructure refinement as well as the mixing of the second phase or the ceramic material into the metal matrix. Now you will ask a question, what is the size of those second phase ceramic particles, right? That also play very important role. So in casting you have a lot of defects, and then you have, this is the friction stir processing where you are refining the microstructure, and then you can see you are going from various micron to the submicron or sometimes the nano scale. So in casting you have the very rough surface, right, and then also a lot of porosities, voids, defects are there, and also grains grains are mostly dendritic grains in the most of the castings. But when you are doing this process, you are refining the dendritic grains, and it is becoming more refined, which will improve the properties of the component. So that is the advantage from the from shifting, not shifting, at least integrating this friction stir engineering into your casting. Then now because all of you are from the industry, so you also understand the what is the market demand of these materials, right? So these materials are being used in different domains, starting from aerospace, automotives, and the marine, and also repair and remanufacturing, and it also has a lot of business opportunities for a lot of industries. Now about the aluminum global market also you are aware, but here I would like to focus this composite material has lot of benefit when you talk about the high performance materials, right? All of your castings are being used in regular applications, and but when you talk about the upgradation, and also it should meet the requirement of the current scenario, then these type of materials come into the picture. And then you also talk about the nanotechnology, or you are going to mix the nano materials into the metal. So basically you are embedding the nano materials into your aluminum matrix, and that is how you will improve the properties and performance. Now, so here I would like to share here. So what I would like to convey here is you have the casting process, but if you can integrate this friction stir engineering into your castings to improve the properties and also the performance, then you have a very good scope to play an important role in the aluminum casting market. And there are different varieties of particles or ceramic materials which you can use. Even today, a lot of research is going on in developing the new type of materials. So these materials are all available in the market, but research is going on to develop or making these materials more smart, right? So there are some specific ceramic materials which can also play important role. Let us say shape memory ceramics, right? Based on your demand, they can perform as per your needs, right? So, but it also fulfill the requirement of various industries. So here, so you have the this will be the advanced approach to integrate the friction stir engineering approach to your castings. So you can have the friction stir processing, you can have the nano reinforced materials, and also additives. Right today, the additive manufacturing or 3D printing is now pervasive in all the domains. You talk about the aerospace, you talk about the automotives, because they want to produce more components in a less time. But in additive manufacturing also, they are facing a lot of problems. The same defect which we talk in the casting, the same defect they are also talking. They are saying, I have made a additive manufactured component using 3D printing process, but they have the defects, right? They are not getting the what we call the fusion bonding between the layer by layer, right? So, but if we can integrate this friction stir engineering into those, even the 3D components, right? We are going to refine the microstructure as well as the bonding between the layers. So that is how we can improve the performance of the components. So it has applications in automotives, aerospace, even the construction industries, and also in energy and electrical systems also it has application. So now we can also understand the future scope of this. Now today we are also talking about the electric vehicles, right? In electric vehicles we need lightweighting. So aluminum also plays important role in electric vehicles. Although they are using the lot of FRP based composite materials in the EVs, but there are different. Let us say, for example, EV battery enclosure. So for EV battery enclosure, they need aluminum based materials. So now currently they are using the existing materials, but aluminum, this EV battery enclosure requires a lot of lot of stuff, lot of properties which are not available now in the system. So these type of engineering we can include, and also the surface engineering we have to play very important role, and also smart nano hybrid composites also, they are the next gen materials. And so we are going to shift from bulk to from bulk aluminum to the high performance aluminum composites. So we all deal with here, but we also talk about the defects. We also talk about the the microstructure is not good. But when we go for the high performance composite materials, we have to basically think about these advanced approaches to integrate. It has very good global market. So if you study the global market of these aluminum composites, it is USD 7.6 to 8 billion dollar, and Indian market also it is very good, and it is playing very important role in industry, 10 to 15% in automotive, and 5 to 8% in aerospace, because being a light material, aluminum is being used in many applications. Electrical energy and also construction 70%. So it has very good opportunities for the industries to adopt these type of advanced technologies. So these type of aluminum composites will give you the lightweight, as you know, high strength and durability. So see, you need high strength, but at the same time you also need more toughness. Right? If you have more high strength and not toughness, your component is going to fail very soon. Right? So you need durability. You also need corrosion and wear resistance, thermal stability, and also the stability in the operation when the component is being used. So the future outlook, if you understand this, aluminum composite market is very good. Understanding the advanced approach and starting from the building blocks to the component level, it will give you the high performance. So if you see the market, there are already studies are done and some industries are being used this process. So these are the different components few industries are making using the die casting process, and they are using this friction stir engineering process wherever they want to make the weld. It will also help to reduce the weight, right, to the material, because in welding process we are using conventional welding processes. In conventional welding you are using, basically it is a melting and solidification. So again you talk about the defects, but if you can use this friction stir processing or approach, then you can do easy weldings, and also you are not adding the more weight, and also you are removing all the defects which are there in the conventional welding process. So this is the established process our defense industry is using, aerospace industry is using for critical applications. So friction stir engineering, it is a game changer for automotive aluminum industries if they understand the process and adapt properly. Now, to understand the fundamental how this mechanism works. So, being a student of the engineering, you can consider we study actually the strengthening mechanisms from this perspective. One is the grain refinement. You have to refine the microstructure of your castings. If microstructure is not good, your casting will not sustain for a long time. And then we also study the oro strengthening. So we talk about at the micro level or nano level. We have lot of mechanisms are being operative in the material. So we study about the dislocations. So those, when your component is being used, right, it is experiencing lot of static or dynamic loading, right. So when components goes under these type of loadings, right, these type of mechanisms will be activated, and they will decide whether the component will be last for a long time or it will have short life, right. So these type of fundamentals, just for your information. Now we have conducted few studies how you can introduce these second phase or ceramic materials inside the aluminum. So we have done few studies where we could embed these ceramic particles around 5 to 10 nanometer scale, and we could see the strength rise up. So this is the example where we have done the study on copper based materials. We have mixed the ceramic materials, that is known as polymer derived ceramics, and for high temperature applications. So we could see that strength also is increasing, and also the durability or toughness also is increasing for the composite materials. So that is how you are maintaining the strength as well as you are maintaining. So this type of study we have done on aluminum, we have done on copper, even we also have done on aluminum and graphene based materials, where we could see the very good the improvement in the property. Strength is going up and the toughness also is going up. So I will quickly just spend little time on the current study which we are doing. So now this approach also can be used for deposition, additive manufacturing. Okay, you can also deposit the metal. You can also deposit the aluminum based composite materials. Okay, so we used 70 series, 7000 series alloy, and we use the what do you call the Syria stabilized zirconia. This is one of these shape memory ceramic material, and also polymer dried ceramic materials. This is silicon based ceramic materials which we process in the lab. So we have used these materials for doing the experiments, and we did experiment in our common milling machines in the lab and to understand the physics behind this experiment, and we could actually deposit these layers, composite layers, and we could deposit almost 3.7 to 4 mm thickness composite materials using this. And you can see the distribution of the second phase particles inside the matrix. There is no defect, right, compared to the casting, right? And you can deposit layer by layer, right? So this study we have done at 100, so you can see the scale of 100 micron. And so the beauty of this process is the microstructure and refinement of the particles. Now you can also see this is basically we study the microstructure using the electron backscatter diffraction techniques, right? So you can see here these are microstructure, and you can see the average grain size of around 6 micron, right? So this is how we can refine the microstructure, and also we study the fundamentals. So we do all the microstructural engineering after making these materials, and also we can go to the nano scale. So this is a scale where 500 nanometer, this is 200 nanometer, right? So at this scale we go and see what is happening in the material. Okay, all those the mechanism which I have shown in the last slide, all those mechanisms we can understand at this scale only, because we cannot see those things at the macro scale, right? So these type of studies just for your showing, and this type of then we do the measurement which strengthening mechanism is more active. So that also we can evaluate and understand the performance of the material. So this is the study of hardness. We have seen significant improvement, and also so you can see here in this also we can see the significant improvement in the mechanical properties. Yeah, this is the common practice which we have. So this is basically the severe plastic deformation. Okay, so at what speed you do this severe plastic deformation, that will decide the performance of the material. Now I also want to show you a few slides on corrosion. Many aluminum alloys components are being used in various places where you have to take care of the corrosion, and because when you refine the microstructure at the micro scale or nano scale, you can also you are addressing that corrosion resistance also will increase, because that is also becomes the very prone in this. So we have done this type of study where we could see, you can see here in this study, we can refine the microstructure at the micro, submicron scale, and we have done this corrosion testing, which has shown very good corrosion resistance in these alloys, right? So by and large, I would like to convey here is in these castings, if you want to improve the properties and performance, right? Considering the real-time scenario, the demand of the current scenario, we should integrate such techniques with our existing process, so that we can fulfill the requirement of the customers and then sustain in the market. So with this, I thank you for your time, and I look forward for your questions and answers.
Thank you, sir. Do we have any questions from Dr. Ajay?
Come to aluminum.
Yeah, so we have done the study on graphene layers, on graphene and aluminium. So we use the aluminium A356 alloy, and this is the result which we have published. We have used the GNP, graphene nanoplatelets. We have used graphene nanoplatelets in A356 alloy, which is the automotive alloy, and we could see a significant improvement.
Is there any heat transfer? Talk about heat transfer. Increasing the heat transfer coefficient.
Now that heat transfer study we have not done. We have only done the study to understand the strength wise. Now here one more point I will add. Many castings graphite is being used for different purposes, right? And the graphite actually is having the very less wettability with aluminium, right? To increase the wettability is also a challenge. So when you mix the graphite or carbon in the aluminium, melt aluminium, it will agglomerate very fast. It will agglomerate, and now being a casting person, you have to disperse uniformly, right? And so this process, this friction-based process is helping to exfoliate those graphene layers in many ways, okay? Because you are using the shearing process. Friction is basically shearing operation. So when you have the graphite, you are applying the shearing force and then keep on exfoliating. So graphene is basically exfoliation, right? There are different chemical techniques. So this process actually we could do exfoliation of these multi-layer graphene into 2 or 3 or 4 layers of graphene. So that is the advantage of mixing these graphene layers using this process, I am saying.
When in a solid condition.
In solid condition. So we have not done in melting, we have done in the solid condition.
Right.
Because in melting is difficult. Melting you get chunk of graphite agglomerated at one place, and that's difficult.
So you're taking the carbon by force into the...
Yes.
Base.
Somehow we are embedding we are making coating of those graphene nanoplatelets over the metal, and then we are applying this process for further exfoliation and distribution.
Thank you, sir.
Yeah.
Thank you, sir. I now call upon Mr. K.S. Anduthavan, our Organizing Committee Chairman, 16th Aluminum Conference 2026, to felicitate Dr. Ajay Kumar with our traditional Angastram and a specially curated gift.